Hi friends, welcome back to new session. In the last session, we had seen justification for the statement that a commutator makes rotor MMF stationary in space, or I can say commutator makes rotor MMF stationary with respect to stator MMF. So for this statement I had given justification, and if you see before that video, if you see we have explained about a commutator. Okay, so in that commutator, if you observe clearly, commutator segments are made up of hard drawn copper, nothing but I can say metal, and number of commutator segments I got number of coils. And if you see, you have to remember one thing in that video. So always brushes will be fixed, they won't move, whereas commutator segments or I can say split rings will be moving. Okay, so brushes is nothing but brushes are fixed, whereas segments are moving. That thing you have to understand. Okay, and in the video, I think in the previous videos I explained about commutator and field magnet. In that field magnet also you are having pole core, pole shoe, field winding is there. So that we explained clearly, and we explained about armature core also. And if you see construction of a DC machine first video, we explained about magnetic frame or yoke. Okay, we explained about function of pole core, pole shoe, all those things we had seen clearly. So in this session also I will be continuing to this construction of DC machines topic only, guys. But in this video I am just going to discuss about brushes and armature winding. Armature winding means we will be having generally a lap winding and a wave winding in DC machine. So in this video I am just going to discuss lap winding. In the next video I will be discussing wave winding. Okay, so guys, first of all let me discuss about brushes. So tell me, so what is the use of brushes in case of DC generator or in case of DC motor? You please tell me. See, in a DC generator, because of generator action, whatever EMF or current induced in armature winding, from that armature winding current will be coming to commutator segments, or I can say split rings. Okay, or I can say commutator. From split rings current will come to brushes, from brushes current will go to load. That means in a DC generator, so brushes gives current to the load, it collects current from armature winding through commutator segments, or I can say split rings, or I can say commutator. So after collecting current from armature winding, it gives current to the load. In case of DC motor, you tell me in DC motor we are giving DC supply, no? So brushes takes DC supply and gives supply to armature winding through, I can say once again, commutator segments or split rings, or I can say commutator. Okay, so this is a function of brushes in DC generator and DC motor. So tell me guys, first of all, what is the use of using brushes? Why I have to use brushes? Very simple. Suppose if you see, in example, let me take DC generator. Okay, in DC generator, after EMF induced armature winding, current is coming from armature winding to split rings. Split rings are nothing but a rotating part. It's a rotating portion. Right? Whenever terminal is rotating, when terminals takes out of the machine, when terminals brought out of the machine, so then also if terminals are rotating, how can we apply load to the DC generator? Similarly, if you take DC motor, if terminals are coming outside, if they are rotating, how can we give DC supply to the terminals? Okay, therefore, in case you can take DC machines or you can take synchronous machines also, guys. If you see synchronous machine, you are having salient pole synchronous machine and cylindrical pole synchronous machine. There also we are using brushes. So what is the main use of using brushes is, whatever the terminals coming out of the machine, brushes make those terminals which are coming out of the machine stationary. Thereby you can apply the load or you can give the supply, whatever. Okay, so please note on that point first of all. Please, after keeping heading brushes, note down. In rotating machine, brushes are used to make rotating terminal stationary, when terminals are brought out of the machine. Okay, please stop. Next guys, tell me, so generally brushes are made up of carbon. So let me give a reason why brushes are made up of carbon. See guys, what are the properties of carbon means? Carbon is having self-lubricating nature. Because of the self-lubricating nature, if brushes are made up of carbon, We know already brushes are simply placed in the commutator segments. Commutator is rotating part. So whenever commutator is rotating, there will be some friction between commutator segments and brushes. If brush is made up of carbon which is having self-lubricating nature, you will be having less friction between brushes and commutator segments. So that is the reason why brushes should be made up of carbon. And one more thing, carbon is having high, I can say, thermal stability. High thermal stability. It can withstand high temperature. It can withstand a high temperature. So one more reason, guys, can you please tell me, carbon is having a negative temperature coefficient. That means as temperature increases, resistance will be reduces. Okay, and we'll be discussing in future. If I use carbon brushes, it improves commutation also. So what is commutation? All those things it will come in future videos. So please, as of now, note down these points, guys. Before that, let me give one more. Let me discuss one more point also. Suppose some people may think, sir, we are placing brushes on the commutator segments. Okay. It collects current from the commutator segments, it gives current to the load in case of generator, that is okay. So what is the problem if brushes are made up of metal? Like that people will be thinking. So see guys, commutator segments are made up of hard drawn copper, that already discussed. Nothing but the commutator segments are made up of metal. If a brush also made up of metal, okay, so if metal to metal contact is there, you will be having a more spark will come into picture, which is not desirable. So obviously brush should not be made up of metal, it should be made up of what I can say, carbon only. Please let me give notes up to this, please note down. Yeah, brushes are made up of carbon, brushes are made up of carbon, brushes are made up of carbon, okay, because of following reasons, because of following reasons, because of following reasons, because of following reasons. Number one, carbon is having self-lubricating nature. Carbon is having self-lubricating nature. Carbon is having self-lubricating nature. Thereby less friction between carbon brushes and commutator segments. Thereby less friction between carbon brushes and commutator segments. Okay guys, next point. Carbon can withstand high temperature. Carbon can withstand high temperature. That is carbon brushes is having high thermal stability. High thermal stability. High thermal stability. Okay, next. Carbon is having negative temperature coefficient. Carbon is having negative temperature coefficient. Carbon is having negative temperature coefficient. Full stop. Next, please note down as a note. Since commutator segments are made up of hard drawn copper, you can write in bracket metal. Since commutator segments are made up of hard drawn copper, in bracket metal, just close the bracket. If brushes are made up of metal, then metal to metal contact leads to more sparking. Metal to metal contact leads to more sparking, which is not desirable. So brushes are made up of carbon. Okay, next point. In small DC machines, brushes are made up of carbon. In small DC machines, brushes are made up of carbon. Okay, next point. In large DC machines, brushes are made up of metal graphite, electrographite, electrographite, comma, carbon graphite, comma, carbon graphite. Next guys, here number of brushes is equal to what? What is the formula? Number of brushes equals to, generally number of brushes equals to number of parallel paths. Let me represent number of parallel paths with capital A. See, number of parallel paths depends on the winding which we are using. Suppose example, see, armature winding may be lap winding and it may be wave winding also. Okay. In lap winding guys, in lap winding I am saying number of parallel paths A equal to, please try to understand. So I am saying in a lap winding number of parallel paths A equal to number of poles P. In wave winding also number of parallel paths A equal to 2. What here? 2. Actually number of parallel paths A equal to P, A equal to 2 for lap and wave is correct for simplex winding. Okay. But for duplex and triplex, so your A formula will vary. Actually see, very simple. In general I am saying the number of parallel paths A equal to M into P. Here for wave winding A equal to 2 into M, where M is, I can say, 1 for simplex winding. If winding is a simplex winding, I can say M value will be 1. M equal to 2 for a duplex winding. M equal to 3 for a triplex winding, and so on. Okay. In general, if nothing mentioned, you should take it as a you should take it as a simplex winding where M is 1. So where M is 1, therefore lap winding number of parallel paths becomes the number of poles, and for wave winding number of parallel paths equals to 2. Is it clear guys? Now tell me, I am asking number of brushes formula. Very simple, no? Number of brushes for, I am saying for lap winding, number of brushes is equals to what I said? Number of parallel paths equal to what? I can say P. If simplex winding, okay. For wave winding, I can say once again, number of brushes equals to number of parallel paths, which is equal to how much here? 2. So please try to remember this one, okay. Right, please note on this. Please note on those points. Yeah. See, in addition to these things, so regarding problematic point of view, one point is very important guys. See, brush drop equal to voltage drop across brushes, I can say. Brush drop, let me represent with VBD. Voltage drop across brushes is equal to formula 2 times voltage drop at each brush. This is very important guys, okay. So some people will be having some confusion. Suppose example, let me take here. Suppose if I take a number, if I take example, number of poles is equals to, if I take 2. So if it is a lap winding, then people will think like this, sir, well, for lap winding number of brushes equals to number of poles, no. So number of brushes is equal to number of poles is equal to 2. So that's why you are multiplying with the 2. No, is not correct. It is not correct. Suppose if P equal to 4 he has given, so number of brushes becomes 4. Don't multiply with the 4. That is wrong. Okay, please try to remember. So this brush drop equal to 2 times voltage drop at each brush. This relation is valid irrespective of type of winding. Whether my winding may be lap winding, winding may be wave winding, or one more thing, irrespective of a parallel pass. So irrespective of number of parallel pass, irrespective of type of winding, irrespective of number of brushes, okay, always VBD equals to 2 times voltage drop at each brush. In examination, if they give you voltage, if they give you brush drop this much voltage, you should take brush drop is that much voltage only. Suppose if they give you, instead of giving a brush drop voltage, if they give you voltage drop at each brush, if they give you this term, each term is very important. If they give you voltage drop at each brush, then you should take a VBD equal to 2 into given value. Okay, if he has not mentioned that each, if he has given simply brush drop voltage, indeed he has given this one. If they mention each brush means, then you should multiply with 2. Okay guys, so please remember this relation is valid irrespective of winding, irrespective of type of winding, irrespective of number of parallel pass, irrespective of number of brushes. Always this formula will be, this relation will be valid. Okay, please guys, please note down this relation as a note. Brush drop VBD equals to VBD equal to 2 into voltage drop at each brush, voltage drop at each brush. Okay, you just note down in the bracket. It is always correct. It is always correct irrespective of. It is always correct irrespective of type of winding. It is always correct irrespective of type of winding, comma, irrespective of number of brushes, comma, irrespective of number of parallel pass. Okay, don't confuse. Suppose if poles instead of given 2, if they are given 4, don't multiply with 4. It's 2 into voltage drop at each brush is valid for P poles. It may be 2, 4, 6, 8, whatever. This is valid for lap and wave. This is valid if number of parallel pass are 2, 4, 6, 8, whatever. Okay, so always this relation is valid irrespective of type of winding, irrespective of number of brushes, irrespective of number of parallel pass. Is it clear guys? So please note down this one. Okay, and the next one. Yeah, if brushes are made up of carbon, next point, if brushes are made up of carbon, VBD equal to 2 volts. VBD equals to 2 volts. That means what is the meaning guys? VBD 2 volts means, that means 2 into 1, no? That means here 2 means 2, okay. This 1 means this one. Voltage drop at each brush indirectly it is nothing but 1 volt. 2 into 1, it will be getting 2 volts here, okay. If brush is made up of carbon, VBD equal to 2 volts. Please note down. So generally, commonly we will be taking this value only, because generally I can say commonly brushes are made up of carbon only. That's the reason why VBD should be taken at 2 volts generally. Okay. Next point. If brushes are made up of metal graphite, VBD equal to 0.5 volts. 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 0.5 volts. See, and one more thing I want to let me focus here. What is that? Tell me guys, where generally brushes will be placed. This is a question I am going to ask. Okay, where generally brushes will be placed, whether it is along D axis or along Q axis, I am asking. So for this I had given explanation already in the previous video. So I'm just taking same example which I explained in the previous video. What is that? If you remember, I had taken in the previous videos number of slots equals to, I think I had taken 4 slots, and number of poles equals to 2 poles I had taken, and it is a double layer winding. Okay, so after, see, I explained 2 figures in the previous video. So initially, second figure, if you observe clearly, that is after shifting by 45 degrees, I explained the second figure. Okay, please try to see that figure. So let me draw here, guys. Let me draw here. So let me give justification. Like generally where we have to place brushes, all those things. So for the, I think I had given this point in the previous video itself, but just I'm repeating once again. So it's nothing but north pole, and let me in DC machine we will be placing armature winding on the rotor, and let me take south pole here, because I'm taking 2 poles. I taken 2 poles, north pole, south pole here. Okay. So there is no need to explain once again. Simply I am just in brief I am explaining here. Just let us see. So here we are having 4 slots, right? If you observe clearly, so in the previous example I had taken direction of rotation of rotor in anti-clockwise direction, and after shifting 45 degrees, slots will come to this position. If you observe clearly, slots will come to this position. Please try to have a look. Okay, please try to watch previous video, then it will be easy for you to understand. So this is a position, right? This is a position. Okay, right. And if you observe, let me give numbering also, guys. Here I think I had given here numbering 1, 2, 3, 4, like that I had given numbering. Okay, so if please try to this is the figure after shifting 45 degrees. This is the figure I had taken. Okay, so let me ask one question here, very simple question I am asking here, please try to understand. So I had given explanation also for that. So axis which is passing along poles can be called as, which axis? Polar axis. What is the other name for this axis? D axis, or I can say direct axis. You can say D axis, okay, D axis, right. Generally, in DC machine, always you have to place field winding on the, what here we are placing field winding in the stator, nothing but here only, here field poles will be attached to the stator. In that field poles only you are placing field winding. That means generally our field winding will be placed along which axis? Along, I can say polar axis, like this. Is it clear? Right. And if you observe, guys, clearly in the previous video I explained, I just drawn here one commutator also I just drawn here. Number of commutator segments equals to number of coils. If you see in previous video, it's a double layer winding. So 2 coil sets will be placed in each slot. Top layer, bottom layer, top layer, bottom layer, and top layer and bottom layer. Okay, guys. Okay, so what I am asking here, very simple question I am asking. Number of commutator segments will be equals to number of coils. Here number of coil sets means is a coil set. It's a coil set. 1, 2, 3, 4, 5, 6, 7, 8. But number of coils is equals to number of coil sets by 2. You'll be getting 8 by 2, 4. So 4 segments you should take here. So 1, second segment, third segment, fourth segment, like that you should take. Okay. So this everything I explained in the past, in the previous video. There is no need to explain once again. Here my main thing here is, tell me, please try to observe previous video and tell me what is the type of EMF induced in slot number 4. Is it a cross or dot? Is it cross or dot? I am asking. Please try to think and tell me. If you observe clearly, I had given explanation. You can check afterwards. It's a dot here, and in slot number 2 it's a cross. In slot number 1 and 3 there is no EMF. See, guys, I had given explanation for this in the previous video. Otherwise, let me explain once again. There is no need to confuse. If you observe in what is the formula for dynamic EMF? E equals to BLV sin theta. Yes or no? Here theta is the angle between what and what. It's the angle between linear velocity and magnetic flux density. Always flux lines will be going from north pole surface towards south pole surface. That means it will start from here, it will go to south pole. So let me draw this magnetic flux density here, and I assumed direction of motion of the rotation of the rotor in anti-clockwise direction. So please tell me at slot number 1, so tangential motion becomes like this. This is the direction of motion of the conductor, I can say direction of linear velocity. And what about the direction of flux density? It is from left to right. So what is the angle between these two, V and B? So 180 degrees. So what about sine 180 means we'll be having EMF 0. So there is no EMF here. And similarly, if you observe in slot number, I'm just going anti-clockwise direction, right? For anti-clockwise direction, after slot number 1, you should go to slot number 4. So here, this is the tangential motion of the conductor, velocity of the conductor. And what is the direction of flux density? It is like this. So please once again apply Fleming's right hand rule. When a moving conductor, thumb indicates this V, because the magnetic field, this forefinger means this magnetic flux density, EMF induced. Center finger means out of the board means what? Dot. That one I just showed. And what about at slot number 3, guys? So for anti-clockwise rotation at slot number 3, tangential motion becomes like this. So what is the angle between V and B in this case? Nothing but 0, sine 0, no EMF here. Once again, sine 0 means EMF will be 0 in slot number 3. And what about slot number 2? For anti-clockwise rotation, so here is a tangential motion and this is direction of flux density. So apply Fleming's right hand rule and tell me what is the direction of EMF in slot number 2, conductors. Okay. When a moving conductor, thumb means direction of linear velocity of the conductor, because the magnetic field, forefinger means direction of magnetic flux density. EMF or current is induced in that conductor into the board means what? Cross. That one I just showed here. Right? Is it clear? So here I just want to give explanation why brushes generally, practically no doubt brushes will be placed along D axis only. If you observe clearly in the previous video, guys, so segment number 1, 2, 3, 4 like that. If you observe clearly, after shifting 45 degrees, so one brush will be connected between segment number 1 and 2, and another brush is connected between the segments 3 and 4. That means brushes practically place along D axis only. But generally, if you observe, will be showing like this. What is the reason for this? This is the only thing I am explaining here. Okay. So this is what I can say, Q axis. And what about this one here? I can say D axis. Here only we will be placing field winding like this. This one. Okay. So my question here is, generally brushes are placed along D axis only practically. But generally why we will be showing brushes along Q axis, I am asking. This is the only thing I am just going to explain here. Okay, very simple. See guys, though practically brushes are placed along D axis, okay, but if you observe clearly, EMF induced in the coils. So generally guys, what about this axis, guys? Axis which is passing along poles can be called as polar axis or direct axis or Q axis. And what about quadrature axis is the one which makes 90 degrees electrical with respect to direct axis. Please try to remember, quadrature axis is the one which makes 90 degrees electrical with respect to D axis. So I think in synchronous motion I told one relation, theta electrical equal to P by 2 into theta mechanical. This is the relation I told. For this relation also derived in a synchronous machine. So otherwise just remember formula, that's enough. Theta electrical equals to poles by 2 into theta mechanical. So here how many number of poles I have taken? 2 poles. So please tell me theta electrical equal to 2 by 2 into theta m. So theta electrical will be equal to theta mechanical. So whenever 2 poles are there, so as I told you, theta electrical, theta mechanical both are equal here for P equal to 2 poles. So I already given explanation, I already given definition for quadrature axis. Quadrature axis is the one which makes 90 degrees electrical with respect to D axis. In this example, since poles are 2, electrical angle will be equal to mechanical angle. So please tell me, what is the 90 degrees mechanical angle or 90 degrees electrical angle with respect to D axis? This is what I can say D axis, no? To this with respect to D axis, this is what axis which is making 90 degrees with respect to what I can say, it is making how much angle with respect to D axis? 90 degrees. Okay. So here in this case for P equal to 2 poles, so for P equal to 2 poles, So axis which is perpendicular to, I can say, which is perpendicular to dx, nothing but this one. Quadrature definition, axis which makes 90 degrees electrical with respect to dx is nothing but quadrature axis. So I can call this axis as what? Interpolar axis, axis which is passing between poles. Okay. Or what is the other name? Quadrature axis, quadrature axis, quadrature axis, or I can say q axis, or I can say q axis. Okay guys. Now let me ask one question here. So in this, if you see in this example, what is the EMF induced in coils which are placed along the q axis? Please try to understand. I am asking a question. What is the EMF induced in coils which are placed along q axis? Means in slot number 1, how many number of conductors I just placed here? See, top conductor, bottom conductor. In slot number 3 also top conductor, bottom conductor. I am asking about these conductors. Okay. EMF induced in coils which are placed along q axis is how much? No EMF. No EMF. What is that? No EMF. So here coils which are placed along q axis is short circuited due to brushes. It is short circuited due to brushes, because I told you there is no EMF here. It is short circuit due to brushes. In order to show that phenomena simply, we are representing brushes instead on the d axis. We are representing these brushes along the q axis. Is it clear guys? So please tell me where you have to show brushes here. Brushes should be placed at a location where coils are making 90 degrees with your d axis. Tell me what is that location where coils are making 90 degrees with your d axis? Q axis only. Therefore you have to place brushes along the q axis. Why you have to place brushes along q axis? To show, I mean, whatever I told, one phenomena. What is that phenomena? EMF induced in coils along q axis is 0. Those coils are short circuit due to brushes. In order to show that phenomena simply, we are representing brushes at location, okay, at location where coils are making 90 degrees with respect to d axis, nothing but this q axis only. Along this q axis only we are showing brushes, these brushes, see these brushes. So practically brushes are along the d axis, but so to show that phenomena simply we are showing brushes along the q axis. That's it. See in that figure, do you have any commutator like this? No, I don't have any commutator. So we won't show brushes along the d axis. We'll be showing brushes along the q axis because of the reason which I told. Okay, you please note on that point. Okay, yeah, brushes are actually placed along d axis. Brushes are actually placed along d axis. Brushes are actually placed along d axis or under poles, and coils perpendicular to poles get short circuited due to brushes. And in order to show this phenomena simply, we show brushes at the location where coils being short circuited. What is that location? Nothing but q axis only, no? That is brushes represented along a q axis. Is it clear guys? Please try to understand. This will be useful for us. Okay, they may ask in some complete examinations. So generally where brushes will be placed, all those things will be asked. Okay, just try to remember that. Practically we'll place brushes along D axis, but generally we'll be showing along a Q axis. Okay, right. Now guys, let me explain armature winding, which is very important. If you observe clearly, in a synchronous machine, regarding this armature winding, we explained it. Okay, nothing but we explained concentrated winding, we explained distributed winding, we explained short pitch winding, we explained full pitch winding, we explained integral slot winding and fractional slot winding. If you observe clearly, before explaining those windings, armature windings, we explained some terms which are necessary to understand armature winding. If you observe, so in that terms belongs to armature winding, we explained what is between turn, what is between coil side, distance between two coil sides, nothing but coil span, beta equal to slots per pole. Okay, so and we explained about pole pitch, we explained about slot angle gamma. All those things we explained in synchronous machine. Please try to watch out, try to see once that synchronous machine notes, then it will be easy for you to understand DC machines. Okay, DC machines armature winding. No doubt. Regarding lap and wave, I will be discussing, no doubt. But generally, armature winding means, guys, armature winding AW. Let me take armature winding AW. Armature winding may be concentrated winding CW, simply write concentrated winding CW, and it may be distributed winding DW. Armature winding may be concentrated winding, armature winding may be distributed winding. If you observe clearly concentrated winding, which I explained in synchronous machine, if you please try to refer the topic. If you in concentrated winding, if you observe clearly, entire coils will be placed in two slots only. That means entire weight will be across two slots only. Weight is not uniformly distributed. In case of distributed winding, so entire winding will be distributed along all slots, among all slots. Weight will be distributed uniformly. So those points please try to see. Already if you refer one synchronous machine notes, it will be easy for you. Okay. So here one thing I want to focus here. So if you see, guys, in synchronous machine, if you see, in synchronous machine also, especially salient pole synchronous machine, if you observe. Okay, let me write here salient pole synchronous machine. Synchronous machine also, let me write here salient pole synchronous machine. If you observe salient pole synchronous machine, in salient pole synchronous machine, whatever field winding is there, that field winding is nothing but concentrated winding. What is that? In synchronous machine, that too silent pole synchronous machine, field winding is concentrated winding. Okay, that you have to understand. And one more thing, guys, in a DC machine also, okay, field winding, once again it is a concentrated winding, except in these two applications, in any, if you take in any rotating machine, okay, I can say winding procedure, I can say winding procedure is distributed winding. What is that? Distributed winding. Okay, guys, please note on that point. Yeah. In salient pole synchronous machine, field winding is concentrated. In salient pole synchronous machine, field winding is concentrated. In DC machine, field winding is concentrated. Full stop. Except in these cases, in any rotating machine, generally winding procedure is distributed winding. Okay, so ultimately what is the conclusion? In DC machine, field winding is concentrated, armature winding is a distributed winding. In DC machine, field winding is concentrated, armature winding is distributed. That is the conclusion. Okay, right. Right. Right guys. Next, see, let me take now lap winding. I told you already in DC machine, please I'll repeat once again. If you want, you can note down as a note also. Please note down. In DC machine, field winding is concentrated. Field winding is concentrated. Whereas armature winding is distributed. Whereas armature winding is distributed. Full stop. Okay. So see guys, armature winding is distributed, no doubt. And one more thing, armature winding may be lap winding and may be wave winding. This is also very important. Armature winding may be lap winding and it may be wave winding. Okay. So we are going to explain lap winding in this video. In the next video, I will be discussing about wave winding. Okay. So please let me classify first of all, otherwise you will be having some confusion. In DC machine, see, let me write here. In DC machine, okay, armature winding maybe what I said, lap winding, or it may be what I said, wave winding. Armature winding may be lap winding and armature winding may be wave winding. Okay. So first I am just going to explain lap winding here. Lap winding. So for explaining this lap winding, okay, I'll be taking some example. So please note on that example. So let me give an example so that you'll be having some clarity. Okay. Please let me give one example. Number of slots, I'm just going to take 8 slots. Number of poles, I'm just going to take 4 poles. Okay. And see guys, let me start drawing lap winding. Okay. And one more thing he has given, it is a double layer winding. He mentioned it's a double layer winding and it is a simplex winding. What is that? It's a simplex winding. You know, simplex winding means M becomes how much here? M becomes 1. Okay. Right guys. So now tell me guys, you know, generally coil span formula. So regarding coil span, all those things guys I had given clearly in synchronous machine. Please try to refer once, or simply if you see this a coil, if you take this coil, okay, if you take this coil, it is a AB is a conductor, CD is a conductor. ABCD is a coil. Okay. For this coil, this becomes one coil side, and for this coil, once again this becomes another coil side. Okay. Distance between two coil sides of a coil. If you take this coil, this becomes one coil side and this becomes another coil side. Distance between two coil sides of a coil is nothing but coil span. What is that? Coil span. Let me represent this with beta. What is that? Beta. So for this beta, one formula is there. Beta equals to slots per pole formula is there. You please try to refer synchronous machine guys. Okay. Right. Ultimate, what is the formula for coil span? Slots per pole. This is the formula for coil span, beta. So coil span equals to slots per pole. Slots how much he has taken here? 8 slots. By poles how much? 4. How much coil span? 2. Is it clear guys? Next, see, for explain this lap winding, you should know one basic formula, YC. YC means what? YC is nothing but commutator pitch. What is that? Commutator pitch. Okay. Generally, so there is no need to confuse regarding front pitch, back pitch, you know, front pitch, back pitch, resultant pitch, commutator pitch, and average pitch. All those things will be explaining in the coming videos. But for drawing lap winding, I need commutator pitch value. That's why let me give formula for commutator pitch for lap and wave winding. Okay guys, for lap winding You just note down this inside of your notes. For lap winding, YC equal to plus or minus M is the formula. Plus or minus M is the formula. For wave winding, YC equal to, please note down, for wave winding, YC equal to 2 by P into, so please note down, for wave winding I am saying, for wave winding 2 by P into S plus or minus 1. What is that? S plus or minus 1. So here you should understand M means what I said. It's an order of multiplex, I can say. Order of multiplex. For simplex it becomes 1. For duplex it becomes 2. For triplex it becomes 3. Okay. So commutative pitch formula for lap winding plus or minus M. For wave winding Y is equal to 2 by P plus or minus 2 by P into S plus or minus 1. Okay guys. Here S means slots, P means number of poles, everybody knows that. Here we are given simplex winding. Simplex winding, therefore YC equals, what is the formula? One more thing I want to say here. Here plus is for, progressive winding. Plus is for what? Here I said progressive winding. Progressive winding. If winding goes from left to right, that can be called as a progressive winding. Generally we will be following progressive winding only. Minus is for retrogressive winding. What is that? Retrogressive winding. Retrogressive winding. So where winding goes from right to left. What is that? Right to left. Unless and otherwise mentioned, you should take winding as a progressive winding only. Though it not mention here, you should take it as a progressive winding. For progressive winding, Y is equal to plus M only, where M is 1 because simplex winding. So Y is equal to what, how much here? 1 is the value of a commutator pitch, okay, in this example for lap winding. Okay, please note down this. I'm just going to erase that one. Okay, right. Now this much data is enough for us to draw lap winding. Okay, lap winding. First of all, see guys, let me take here how many number of poles I am having here. 4 poles, right? 4 poles. Please try to follow clearly. I will be explaining very slow only because a figure becomes very difficult for you. If you are not able to follow, so it becomes very difficult for you afterwards. Okay, so please let me go very slow and please try to follow clearly. Okay, there should not be any deviation. Okay, so how many number of poles I'm having here, guys? I'm having 4 poles here. So let me take 4 poles here. Okay, so north pole, north pole. So since I'm having 4 poles, so for having better diagram, let me draw a big one so that we'll be having some clarity. And in our DC machine, you will be placing armature winding on the rotor. So let me have armature winding which is placed on the rotor. Let me take another pole. Okay, and I am having 4 poles. No, let me take another 2 poles here. Right. Now please see. It's a north pole, it's a south pole, north pole, once again south pole. And tell me how many number of slots in this example it is there? 8 slots, right? 8 slots. Let me take 8 slots. So please try to follow slowly. 8 slots. I'm just going to take 8 slots only here, okay. Right. Right, is it clear up to this? So let me give slots numbering also. Slot number 1, slot number 2. So see, these letters maybe I cannot able to see. Please try to write with me, okay. Slot number 1, slot number 2, slot number 3, slot number 4, okay. Slot number 5, slot number 6, slot number 7, slot number 8. Is it clear? Okay. And you know guys, we'll be using which winding? Double layer winding, no? So that means what? In slot number 1, we'll be having a top layer and bottom layer. In slot number 2 also top layer, bottom layer. Slot number 3, top layer, bottom layer. Slot number 4, top layer, bottom layer. Slot number 5, top layer, bottom layer. Slot number 6, top layer, bottom layer. Slot number 7, top layer, bottom layer. Slot number 8, top layer conductor, bottom layer conductor. Up to here, is there any doubt? Okay, right. Next, let me, you know already in DC machine, we'll be placing armature winding in the rotor. Okay, I just place armature winding in the rotor. And you know, commutator also will be placed in the rotor, no? Let me take commutator. Commutator which is placed in the rotor. Is it clear? So let me give segments numbering. How many number of segments will be there? Number of commutator segments will be equal to number of coils. So number of coils, how many here? Please try to see. I told double layer winding means 2 coil sides will be placed in each slot. So in each slot 2 coil sides. Total slots 8. 8 into 16 coil sides. So I can write here in this example I'm having coil sides. How much here? Coil sides is equals to 16. And what about number of coils? Number of coils is equal to number of coil sides by 2. Number of coil sides by 2. Number of coil sides by 2. This you know already, because 2 coil sides gives you 1 coil. This I already told. This is 1 coil side, this is 1 coil side. This becomes a coil. 2 coil sides gives you 1 coil. Okay. So number of coils equal number of coil sides by 2. That becomes 16 by 2. How much? 8. And I told one more thing, guys. What is that? So tell me in double layer. I mean in here in this case, number of commutator segments equals how much? Number of commutator segments. Number of commutator segments is equal to how much? Commutator segments is equal to what is the formula? Number of coils. Number of coils. Tell me how many number of coils in this example I got. I'm having here. Okay, 8. Therefore, number of segments should be taken as 8. Okay. So like this. So I'm just going to take segments like this. I'm just going to take segments like this. You can give numbering as your wish. Okay. Let me give segments numbering. 1 segment, first segment, second segment, third segment, fourth segment, fifth segment, sixth segment, seventh segment, eighth segment, like that. Okay. I'm having total 8 segments. Okay. Please try to note down up to this. Otherwise, you will be having difficult to draw at a time. Okay. So if you want, you can press pause button and you can note down. That will be better for you. Okay. All right. Is it clear, guys? Right. Now, so what I am saying is, so before proceeding here, so please tell me, I am asking here, what is the direction of EMF induced in these coils? Slot number 1, slot number 2, all those I am asking. Okay. So for having a neat diagram, so I need some space. I am just going to erase this portion. Please let me erase this portion. I think you already noted down. So let me erase this portion. Right. Now tell me, guys. I am assuming direction of motion of conductor. I am assuming direction of rotation of rotor. Okay. In clockwise direction, in this example, I am assuming in a clockwise rotation. This is nothing but direction of rotation of rotor, direction of rotation of a conductor I had taken in a clockwise direction. Okay. So guys, so before deciding direction of EMF in this slot number 1, slot number 2, slot number 3, slot number 4, all those things. Okay, first of all, let me draw some developed diagram. Developed diagram very simple. I can say like this, guys. This in the circular conductor only I can draw in a linear fashion like this. In a linear way, I can draw like this. Please let me draw in a linear way. Let me draw this one. Slot number 1. Next, slot number 2. Slot number 3, slot number 4, slot number 5, slot number 6, slot number 7, slot number 8. Okay guys, right. In slot number 1, let me give numbering first of all. 1, 2, 3, 4, 5, 6, 7 and 8 slots. Is it clear? You know, it's a double layer winding, so in each slot we have to place 2 coil sets. One in top layer, another bottom layer. 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 Top layer, bottom layer. Top layer, bottom layer. Top layer, bottom layer. Top layer, bottom layer. Is it clear? Don't confuse. Very simple only. There is nothing to confuse here. See, suppose guys, if you take this portion, if you unfold in this manner, this 1 is nothing but this slot. 2 means this one. 3 means this one. 4 means this one. Next 5. This one, like that. I'm just drawing instead of drawing in circular way, I'm just drawing in a linear fashion. Okay, is it clear, everybody? Right. So, and you know guys, generally will be under this conductor and this under the slots, we have to show this commutated segments also. No? We have to show commutated segments also. Let me show commutated segments means, let me show in this manner. Okay, so like this. Let me give segments also. Yeah, segment number 1, 2, 3, 4, 5, 6, 7. Okay, and we can take 8 like this. Okay, tell me how many number of segments we are having here? 8 segments. No, see, this green color, 1, 2, 3, 4, 5, 6, 7, 8 segments. Okay, this can be called as developed diagram, because you will be having some confusion if I draw in this manner. So that's the reason I had taken in a linear way like that. Okay guys, is it clear? This slots only in linear fashion, just drawn like that, and whatever this commutated segments are there, that commutated segment I just indicate like this. Is it clear, everybody? Okay, right. Now I'm asking one more question. Suppose, so in slot number 1, I'm having the conductors like 1 and 1 dash. Okay, and what are the conductors we are having? We see with slot number 1 is the conductor 1. Top conductor can be taken as 1, bottom conductor can be taken as 1 dash, and this is slot 1. Okay, so 1 is the top conductor name, 1 dash is the our lower conductor name. 1 dash can be taken as a coil. So 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. So like that you can show coils in that slots. Okay, right guys. Now for understanding easily, I'll do one more thing. So instead of showing this 1 dash, instead of showing this one conductor like this circular fashion, so let me show like this. There is nothing to confuse. Please try to let me draw slowly. This conductor 1 only I'm just showing like this. Conductor 1, upper conductor, let me show with a solid line like this, and lower conductor 1 dash can be shown in like this, can be shown in a dotted form like this, Okay guys, is it clear? So let me extend this. So from here I will start, because I need overhang will come here. I need some space here. Therefore, let me draw from here. Okay, let me draw from this manner. This is what I can say 1, and it's what I can say 1 dash. Similarly, in slot number 2, I am having a second conductor. Let me represent with a solid line, and 2 dash conductor. Let me represent with a dotted line. 2 dash. In the third slot also, third conductor and a 3 dash. Okay, 3 and a 3 dash. In the fourth slot also, let me show fourth conductor in this manner. 4 dash. Very simple. There is no need to confuse. Okay. So simply I am representing those things in this manner. 4 and 4 dash. 4 and 4 dash. 5. Fifth conductor, top conductor can be shown with a solid line. 5 dash. Bottom layer conductor can be shown with a dotted line. Sixth slot top conductor can be shown with a solid line. Sixth conductor. Sixth slot bottom conductor can be shown with a dotted line. 6 dash. 1 dash. Okay guys. Similarly, seventh slot top conductor can be shown with a solid line like this. Seventh slot bottom layer conductor can be shown with a dotted line like this. 7 dash. Similarly, eighth slot top conductor with a solid line. Eighth slot bottom conductor with a dotted line. 8 dash. Is it clear guys? Okay. So I need a diagram should be clear. Therefore, this length should be same. I take like this. Length should be same. Right. And bottom side also length should be same. Right. Now please let me show these commutator segments in below of this conductors. Okay, let me show commutator segments here. Okay, right. Okay guys, so let me indicate those commutator segments. I said here I have taken segments, I just divide like this. If you follow clearly, diagram becomes very easy only. It is nothing difficult. Right. Now let me start. Okay, right guys. See guys, first of all, you please try to understand this thing. I'm just going to erase this red color of unfold all those things, because I'm just going to draw a diagram here also. Right guys. I'll show winding in a circular manner, and I'll show winding in a linear fashion also. Okay, simultaneously I'll go step by step. Please try to follow neatly so that you can understand easily. Okay, right. Okay. So guys, let me assume first of all direction of most of the conductor. Let me rotate rotor in clockwise direction in this example. In this example, I'm assuming let direction of TPM means what here? TPM is what? Prime mover torque. In generator, I'm assuming it has a generator portion. So prime mover torque is nothing but input torque for your generator action. I'm assuming it in a clockwise direction. I'm assuming in a clockwise direction. it is rotating with the omega radians per second speed. Is it clear, guys? Okay. So please try to understand clearly. So for clockwise rotation means if you go like this, see it is going from 1 to 2. Mean tangential motion becomes 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. No, 7 to 8 means see 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. That means this is the what direction in a linear fashion. If you want to show the direction of motion of the conductor, direction of rotation of the rotor, that should be in that direction. This arrow mark indicates this one only. This is the arrow mark of direction of motion of the conductor for circular conductor. So if you take a linear fashion, in that linear fashion, if you take a circular means it should tangential motion goes from 1 to 2, 1 to 2, next 2 to 3, 2 to 3, 3 to 4, 4 to 5 means it should be in this manner. It should be like this. Okay. So this is the direction of motion of the conductor. Okay, guys. Now please tell me, I am asking a simple question here. So under this north pole, and one more thing, tell me how many number of poles there here? 4 poles, no? Slots per pole how much? 2. Yes or no? That means let me take 4 poles. In one pole you have to show how many number of slots? 2 slots. That means, guys, this is the slot number 1. In slot number 1 you are having, don't confuse with slots and conductors. Okay. In slot number 1 is a one conductor, is another conductor. Okay, is one coil side, is another coil side. So this total becomes one slot only. This becomes another slot. So slots per pole I am getting 2. Therefore it should be like this. This is what I can say, pole. Slots per pole I got how much here? 2. Therefore slots per pole mean under one pole, let me take it as north pole. Under north pole, how many number of slots are there? Under north pole, how many number of slots should be there here? 2. Therefore I am also taking here 2 slots only, slot number 1, slot number 2. That's it. Similarly, let me proceed to remaining things also. This is nothing but slot number south pole, and I can take this one as once again north pole, and this one can be taken as once again what here? South pole. Is it clear? Yes or no? Is it clear? Right. Now tell me what is the direction of EMF in these slot 1 conductors, in this slot 2 conductors, in this slot 3 conductors. Very simple, guys. You tell me in slot number 1, slot number 2 comes under north pole. From here you should be very careful. Please try to listen. Slot number 1, slot number 2 is under the influence of north pole. I am assuming he is a north pole, no? So slot number 1, slot number 2 is under the influence of what here? North pole. You know, in this slot number 1, in slot number 1 I can say, what is the tangential motion first of all? Tangential motion I am saying. This is the direction of motion of the conductor. So at slot number 1 it should be, arrow mark should be what here? It should be like this. This is the direction of velocity of the conductor. And direction of flux density, always flux length starts from north pole surface. It starts from north pole surface like this. So diagram becomes difficult for you. Please try to follow neatly. For a clockwise rotation at slot number 1, tangential motion means this arrow mark. This red color indicates direction of motion of the conductor with linear velocity v, and this green color from north. Always flux length starts from north pole surface. Therefore this flux length starts from this north pole. This north pole, no? Therefore it starts from north pole surface. Now tell me at slot number 1 what the direction of EMF induced by applying Fleming's right hand rule, guys. When a moving conductor, thumb indicates direction of motion of the conductor, this red color. When a moving conductor curves the magnetic field, this forefinger means direction of this green color. When a moving conductor curves the magnetic field, an EMF or current is induced in that conductor into the board. Into the board means what? Please think about what here. Into the board means what here? Cross. You should be cross. And similarly, slot number 2 also is under the influence of north pole only. So once again here, direction of linear velocity, direction of tangential motion of the conductor will be like this. And here only direction of flux density will be in this manner. So apply Fleming's right hand rule here and tell me, when a moving conductor, thumb indicates direction of this red color. When a moving conductor curves the magnetic field, forefinger means direction of this green color, and EMF is induced in that conductor. So into the board means what here? Cross once again. So here I should take a cross. Okay, guys. So please be careful. You apply Fleming's right hand rule in all conductors. Here one thing you have to remember, only one thing, tangential motion of the conductor means you should see this one. And for seeing this green color, for seeing this flux density, you please try to see north pole is which one, south pole is which one. Suppose is 1 and 2 is under the influence of north pole. 3 and 4 is under the influence of which one? 3 slot and 4th slot is under the influence of south pole. South pole means generally you know that south pole means always flux lines will be coming towards south pole surface. Arrow mark should be like that. It should be upwards. Is it clear? Because always flux lines will be starting from north pole surface. It will go towards south pole surface. If it is north pole, I have taken like this, no? Because flux lines start from north pole surface. That means you have taken like this. If it is south pole, arrow mark should be like that. Now tell me at the third slot, what is the tangential motion, guys? If you take a clockwise rotation, for clockwise it should be like this, no? And this is what I can say, direction of linear velocity of the conductor, and this becomes a direction of, I can say, flux density. Now apply Fleming's right hand rule when a moving conductor. So this thumb indicates this red color, velocity of the conductor, curves the magnetic field. Forefinger indicates direction of this green color, and EMF is induced in that conductor. Means what here? Dot. So you are going to have in slot number 3. So direction of EMF is dot. You are getting here. Similarly, in slot number 4 also, here we should take slot number 4 means it is under the influence of south pole only. So flux lines direction should be upwards, still it should be upwards only. And once again, tangential motion means you should take for clockwise rotation, tangential motion will be like this. When a moving conductor, sorry, so the velocity of the conductor, okay. When a moving conductor cuts the magnetic field and EMF is induced. Once again out of the board, dot. So I think there is no need to waste time for explaining Fleming's right hand rule in each and every slot. Okay. I explained slot number 1, slot number 2, slot number 3, slot number 4. You please go ahead with the 5th slot, 6th slot, 7th and 8th. Okay. 5th slot means what here? 5th slot, 6th slot is under the north pole. Okay. Therefore, 5th slot, 6th slot is under the north pole. You please tell me, north pole means once again direction of flux lines will be, don't confuse. If I here north pole is surface this one, so always flux lines start from north pole surface. That's why arrow mark should be like this. Here arrow mark of direction of magnetic field should be like this. Why? What is the reason? Because it's north pole surface. You should be leaving from north pole surface. Always flux lines start from north pole surface, right? Therefore, it should be like this. It should be like this. Now tell me, what is the tangential motion at 5th slot? For clockwise rotation, it should be like this. It should be like this. Okay. Now tell me. I think you can able to tell answer. So this the thumb means downward, this red color, because the magnetic field down should be like this. Okay. EMF induced into the board means what here? Cross. So it should show cross in the 5th slot conductors. So similarly, please go ahead in the 6th slot, you will get once again cross. In the 7th slot and 8th slot, you will be getting dot. Okay guys, please, I am just going to erase all those things. After knowing direction of EMF induced, I don't need this B direction, the V direction, all those things. I am just going to erase all those things. Okay, please let me erase this portion so that diagram becomes very simple to you. Okay, so apply Fleming's right hand rule and you will get answer, all those things. Okay, right. Is it clear? Right. Now let me proceed. So tell me guys, in slot number 1, what is the type of EMF induced you got? Cross. Cross means what? Please tell me. Cross means what? Entering into the board, no? Entering into the board. So I am asking now you to tell me the direction of current induced in this slot number 1 and slot number 2. I am asking. In slot number 1, you are having 1 is the conductor, 1 dash is the conductor. You are saying direction of current is cross. Cross means tell me in a linear fashion how can I show arrow mark? Should be upwards or downwards? Very simple. See guys, don't confuse. Suppose if one coil is this one is this one. An example, let me take 1 dash also, one more conductor. So for explaining point of view, I am just drawing like this. To be frank, it should be like this. It will be like this. Okay. In fact, these coils will be like this. Example, if you take a first conductor I am just showing like this, but to be frank, it is like this, no? So now tell me, into the board means, tell me guys, into the board means direction of current into the board means what I am saying. Into the board, I am getting here cross, you are getting, right? Direction of current in the slot number in conductor 1, you are getting cross. Cross means what? Entering into the board. Yes or no? Into the board means that arrow mark should be like this. Please see, arrow mark should be like this. Into the board, direction of current should be like this. Okay, that means that arrow mark only I am just showing like this. Don't confuse with this. So cross direction of current I can show in this manner. Is there any doubt? Very simple. In slot number 1, whatever the conductors I am having 1 and 1 dash, there I am getting cross. Cross means direction of current entering into the board. Into the board means, why you may get one doubt, why I am showing upwards means very simple. See, upward arrow mark, if you take like this guys, if you place conductor like this, that is upwards. But in fact conductors will be like this. That upward arrow mark becomes now what? It is entering into the board, no? Into the board. Therefore simply cross means you should show what? Upward arrow mark. That's it. That is indirectly it is into the board only. If I place conductors like this, that becomes into the board only. Now guys, under north pole, whatever conductors you are having, so everywhere please try to show upward arrow mark, upward arrow mark. In slot number, in south pole, if you take a third slot and fourth slot, if you take example, so in slot number 3, if you take third conductor and 3 dash conductor, okay, you are getting direction of current dot. Dot means what? Out of the board. Out of the board means, try to see here, out of the board can be shown like this. There is nothing to confuse. Downwards, it should be downwards. In slot number 3 and slot number 4, you are getting direction of current dot. Dot should be written as, dot should be shown in this manner. Top to bottom. Why? Suppose dot means out of the board. If I show like this coil, practically it will be like this. Out of the board means arrow mark is like this only, no? Suppose if you see this arrow mark, whatever you wrote here, it is like this, no? It is like this. Initially this is the situation. Suppose if I place like this, that arrow mark is coming from the board only. Coming from the board only. That means indirectly dot only. That means cross means I can show upwards. Dot means I can show downwards. Okay, there is nothing to confuse. So already I think I explained in symbol loop diagram. So north pole and whatever the conductors under the north pole, so there I have to show current, direction of current upwards, like this. Here also upwards, here also upwards, here also upwards, here also upwards, and whatever the conductors under south pole, downwards, here downwards and downwards. Is it clear? Up to here is very simple. Everybody can do this. Still now I did not start my designing. Is it clear guys? So still now anybody can do, okay, no problem. But now let me start my journey. Let me start designing a lap winding. Okay guys, now please. So tell me, generally I'll be going from 1 to, here's, if you see slot number 1, top conductor is connected to whom? From 1 to where I should go? That is very important. From 1 to where I should go, that is very important. So how can you decide from 1 to where I should go means, so this I am just going to erase this one also. I am just erasing direction of most of the conductor. So please guys, so here let me, can I erase this portion? It is not necessary. This one already I just drawn here, okay. Right. Now please see, let me draw here coils. And I can say commutator. Okay guys, so 1 to where I should go, that is my question. So 1 to where I should go means that is decided by 1 to 1 plus Coil span beta. Coil span beta. Tell me beta value how much? 2. Therefore 1 2 you should go. I think 1 plus beta. What is the value of beta? 1 plus 2. That means you should go from 1 to how much here? 3. This is very important. Okay. 1 2 3 should go. That too, don't confuse. Double layer winding designing means you have to start in slot number 1 top conductor, means from here you have to start. See, from here you have to start. Let me try here first of all. So top in slot number 1 top conductor is connected to in a slot. I should go from 1 to 3. No, that means slot number 3 you should give connection to lower conductor. That is very important. Designing in slot number 1 top conductor is connected to slot number 1. This is the top conductor. This is the lower conductor. Okay, top conductor, bottom conductor, upper conductor, lower conductor. Okay, so top conductor is connected to third slot, lower conductor. Third slot, lower conductor. That is very important. So from slot number 1, top conductor is connected to slot number 3. Bottom conductor, that's it. That means let me draw here. Slot number 1, top conductor means what? Is the solid line. 2, slot number 3, lower conductor means what? 3 dash. So let me give connection like this. Okay guys, don't confuse them. From 1 to 3 dash I'm just going, that's it. 1 to 3 dash I'm just going. Is it clear? Next tell me from second slot top conductor is going to whom here? Second slot top conductor is going to, I can write here 2 plus, what is the value of beta? 2, no? 2 I can say 4. Don't write 4, you should go to from 2 to 4 dash you should go. See, 1 to 2 to 2 plus beta. What is the value of beta? 2. Already beta value is 2 value. 2 to 2 plus 2, 4. 4 in the slot number 4, you should give connection to lower conductor. That means see, second slot top conductor is connected to, connected to fourth slot bottom conductor. Fourth slot bottom one. Fourth slot bottom one. Is it clear guys? Yes. Second slot top conductor means here solid one is connected to fourth slot bottom means this 4 dash mean a dotted line. Let me give connection here. Very simple only. There is nothing to worry, but you should be having some patience. Once if you understand, subject becomes very easy to you. Okay. Please try to have patience. Okay. Right. So for having some neat diagram, no. This point should be exact point should be same. That's why let me draw some reference line. After that, I'm just going to erase that line. No problem. Okay. Next, guys, tell me next one. What is that? So next, third slot top conductor means this one. It is connected to 3 plus 3 to 3 plus 2, nothing but 5. That means in the third slot top conductor is connected to fifth slot lower one. So from fifth lower one is this one. Okay. Third slot top one means this one. Okay. Fifth slot lower means this one. Is it clear guys? Right. So let me connect here also. The 3 to 5 dash. 3 to 5 dash means here. It should be somewhere here. Okay guys? Right. Next. Let me extend these lines, okay? Right. Next, fourth slot top conductor is connected to 4 plus, 4 plus 2, 4 plus beta you should take 6, nothing but fourth slot top is connected to sixth slot below one, sixth slot lower conductor. Okay, so fourth slot top is here, sixth slot below means here. Okay, so it should be like this. Below means it should be connection should be like this. Okay, sir, no. So let me have correction here also. Fourth slot top one means solid one. 6th slot lower means the same in this dot line 6 dash. So let me give connection. Okay guys, next 5th slot top one is connected to 5 is connected to 5 plus what 2 nothing but what I can say 7. So 5th slot top one is connected to 7th slot lower. So 5th slot top is here, 7th lower is here. Okay, so you should give connection like this. Okay guys, 5th slot top means here, 7th slot lower means this one. Let me give connection like this. Okay, next 6th slot upper one, 6th is connected to 6 plus 2, I can say 8 I can say, to be frank, you should write 8 dash. Okay, so write 8 dash. So 6th slot upper is here, 8th is lower is here. Let me give connection here. 8th slot lower is here. Let me give connection like this. Is it clear? So 6th slot upper, yes, here. Now 8th dash lower is here. Okay, let me give connection. Right, in this manner. Is it clear? So please guys, don't confuse here. 1 to 3 dash you please write for better understanding. 2 to 4 dash, 3 to 5 dash, 4 to 6 dash, 5 to 7 dash, 6 to 8 dash, like that. Okay, next remaining also please let me complete that. 7th slot upper connector is connected to 7 plus 2 guys, means what? I can say 9. So but how many number of slots we are having here? 8 only. So 9 minus 8, what? 1 dash. Okay, so it should be here actually 9 dash, which is equal to, I can say, 1 dash. Okay, so 7th slot upper one is here. Okay, first slot lower one is here. Let me give connection here. So 7th slot upper is here, first slot lower is here. Let me give connection in this manner. Okay guys, next what about 8th one? Last one I am saying. 8th slot upper connect is connected to 8 plus 2, nothing but 10 dash. 10 dash means how much? 2 dash, because total number of slots 8 only. 10 minus 8, 2 dash you should write. I mean top is connected to bottom, no, therefore you are getting a 10 minus 8 means 2 dash you should write. Okay, so please let me complete this one also. 8th slot, I can say that what I said. So please here, please try to understand here. Here 6th slot upper, 6th slot upper is connected to whom here I said here 6 to 8 dash, no, 6th slot upper is connected to 8th slot lower means this one guys. Please try to excuse this one. This is nothing but lower means this portion, not upper one. Okay, please try to modify that. 6 to 8 dash, 8 dash is lower man, it should be here, not here. Okay, next let me repeat. 8th slot upper means 8th slot upper means this one is connected to 2 dash. This is here 2 dash. So let me complete this. 8th slot top is connected to, okay, I can say 2nd slot lower. Yes, this one. Okay, let me show here. So before that you should show this one also. 7 to 1 dash also you should show. Okay, let me show 7 to 1 dash also. 7th slot upper conductor means 7 will be connected to whom here? It should be go to what? 1 dash. Similarly 8th slot upper is connected to 2nd slot lower. It should be like this. 2, I can say 2 dash. Okay guys, see I wrote it 2 1 dash. From where it is going? From 7. So please let me here, the 2 1 dash is here, no, this 1 dash is here. So let me show in this manner. Yes, it is coming from whom here? From what? See, from 7 to 1 dash. This 1 dash from 7. Next 2 8 to 2 dash. This is what I can say 2 dash. From 8 it is coming. From 8 it is coming. From 8 it is coming. Is it clear? Okay, this is the diagram. And you may get one more doubt. So here one thing you should be very careful. So I think in a coil, I mean one end is connected, okay. And you should be very careful with another end connection. What is that another end connection? So this another end should be connected to what here I can say? Commutator segments. That is very, very important. What is that? How can you connect that? How can you connect that? So very simple. There is nothing to confuse. So let me go very slow. It will be very easy for you. I'll make you very easy. Now tell me guys. Slot number 1 top conductor. Slot number 1 top conductor is connected to commutator segment 1. So I can say like this, okay, see, okay, let me give numbering also, let me change numbering, from here it will start 1, 2, 3, 4, 5, 6, 7, 8. That is also correct, okay, no problem, but for better, for having neat diagram, I just change nomenclature, okay, see guys, see first slot top cut with this one. It is going from here to segment number 1 means this one. See, please be careful. No doubt you cannot able to understand clearly, but I am just writing, I am just saying. So just listen my voice and just try to draw in your notes. First slot upper one is connected to segment number 1 and it should be extended to second slot lower one. Okay. So first slot upper conductor means first conductor is this one. So from here 1 is connected to segment number 1 like this. So before that, do one thing guys. Let me do one thing. Let me take wires from these segments. Let me take wires from this segment. Wires from this segment and tell me. I said first slot top conductor is connected to first segment and it is extended to second slot lower one. So let me represent this here. First slot top conductor means the solid line 1 is connected to whom here? Is connected to, I can say, is connected to segment number 1 in this manner, okay, and it is extended to 2 dash, it is extended to second slot lower means what? In the second slot lower is about 2 dash, that 2 dash also connected to what? I can say complete segment 1 only. So that means 2 dash is here, 2 dash is here. Let me connect this, let me connect this with this one. Okay guys, next, like this simply you have to follow. Okay, now tell me, second slot top conductor means this one is connected to second segment like this, second segment like this, and it is extended to third slot lower one. So let me represent here. Second slot top means this one, it is connected to second segment means it should be like this, and second slot top is connected to segment number 2, it is extended to third slot lower means 3 dash is connected to second segment only once again. 3 dash means here it should be connected to second segment only. Is it clear guys? Next, so let me proceed. Third slot upper one is connected to third segment. It's connected to third segment like this and it is extended to fourth slot lower means like this. See, third slot upper means the solid line connected to third segment, and what I said that segment third segment is extended to fourth slot lower means 4 dash. So 4 dash is here, it should be extended to here. You do one thing, let me write here also 1, 2, 3 dash what it is there. See, 1 is this conductor, 3 dash is this one. If you observe clearly, 1 conductor is connected to segment number 1, okay, 1, 2, and 3 dash is connected to which one? 3 dash means this one. This is connected with segment 2, right? Next, second conductor, second means this one, second is connected to whom here? Second segment, okay. Next, 4 dash is connected to whom? 4 dash means this conductor is connected to once again, you can say 3. Next, let me repeat this one, let me go further. Third conductor means this one, it is connected to whom here? Third segment, and 5 dash is connected to whom here? 5 dash. Okay, let me proceed. I'm just still now what I did, I completed. Now let me proceed. So guys, now let me proceed here. Before that, you should write this one also. No? Fourth slot upper conductor means connected to what I said? Fourth segment. It is extended to fifth slot lower. So fourth slot upper means this one, it is connected to segment number 4, okay, and it is extended to phi dash, means phi dash is here, it is connected to what here I can say, this segment. Is it clear? If you want you can complete now. Fourth conductor is connected to which segment? 4. This one. Okay, let me repeat this one also. Phi dash. Phi dash is connected to whom here? Phi dash is connected to whom? 4. And here, otherwise you do one thing. Let me complete this, then I can draw. Then I can write down here. Then I can write here. It will be easy for you. Okay, guys. Right. Now I completed 4. Now please let me proceed. Fifth slot upper means this one is connected to fifth segment, means like this, and it is extended to sixth slot lower. Okay, so fifth slot upper means this one, it is connected to fifth segment like this. It is extended to 6 dash, means 6 dash will be connected to like this. Is it clear, guys? Right. Next, sixth slot upper is connected to sixth segment like this, and it is extended to seventh slot lower. So sixth slot upper means this solid one connected to sixth segment like this. It is extended to 7 dash, means it should be like this. It should be like this. Is it clear, guys? Next, seventh slot upper is connected to seventh segment. It is extended to eighth slot lower. Eighth slot lower. Okay. Slot number 8. Okay, his slot layer. For showing slot numbers, I just use a black color. 8. So seventh slot upper is connected to seventh segment. It is extended to eighth slot lower, means 8 dash. So seventh slot upper means this one. It is connected to seventh segment like this. Okay, it is extended to 8 dash, means 8 dash will be connected here. Okay. Similarly, let me complete this one also. Eighth slot upper is connected to eighth segment. It is extended to 1 dash. So if you see eighth conductor, it will be connected to eighth segment. But I cannot able to see here. It is eighth segment here. No problem. Leave it. Now what about it is extended to 1 dash? I said it is extended to 1 dash. So 1 dash will be connected to I can say this eighth segment. Okay, right. If you are having doubt, you can I'll do one thing. This 8 only I'll for understanding purpose I can draw like this. Eighth slot only I'm just drawing like this. This eighth slot, eighth conductor I said it is connected to eighth segment. No, but segment is here 8 conductor is there. Therefore, for your understanding point of 8 I'm just drawing here. It is connected to I said 8th segment. I can show like this. It's better. Okay, guys. Is it clear? Now let me decide direction of currents here. So in segment number 1, guys, segment number 1, see it is connected to what I said, coil, conductor number 1 and conductor number 2, no, 2 dash, no. Conductor number 1 is arrow mark upwards, here also upwards. Both upward means here some current is there, no, definitely it is coming, it is dividing like this. Okay, so definitely you will be having brush to segment 1, to segment 1. What is that current also? Direction of current, it should be upwards. Next, guys, if you see segment number 2, it is connected to I can say second current is upwards. So let me show upward arrow mark here, and it is connected to what I said, this 3 dash, it is downwards. If you apply KCL, it is upwards, downwards. There is no current, result current. Okay, there is no need to show brush here. Okay. Now what about third segment current? Third segment is connected to 3. It is down. Arrow mark should be downwards. Yes, it should be downwards. And third segment is connected to 4 dash. Also, it should be downwards. So result current is there. It should be in downward direction. So brush has to be placed here. It should be arrow mark should be. Current direction should be like this. It should be up downwards. And what about fourth segment, guys? Fourth segment is connected to fourth conductor. It is arrow mark is downwards, and here it is connected to 5 dash. It is upwards. Do you have any result current here? No, there is no need to show brush here. Next, similarly, what about fifth segment, please, guys? Fifth segment is connected to fifth conductor. It is upward arrow mark here because upwards, no, that upward arrow mark I'm just showing here. and here it is connected to 6 dash, it is also upward here. So resultant current is there in upward direction. So I have to show brush here. I need to show brush here. So this is what I can say, upward direction arrow mark. And what about segment number 6, guys? Segment number 6 I am saying. Segment number 6, if you see, it is connected to 6th connect upward arrow mark, 6th connect upward arrow mark, and it is connected to 7 dash downward arrow mark. Do you have any resonant current here? Upward, downward. If you apply KCL, there is no resonant current here, okay? And if you see 7th segment, if you see, it is connected to 7th connect arrow mark downwards, and it is connected to 8 dash arrow mark downwards. Once again, resonant current is there. I can show, I can have some brush to this segment. You say 7th segment. It should be downwards. Is it clear, guys? And what about this 8th segment? 8th segment, if you see, from 8th conductor arrow mark is the current direction. And what about this one? 1 dash is upwards. Do you have any resonant current here? No, there is no need to show brush here. Is it clear? So this brushes only general will be placing here, but if I show here, it will be difficult for you to understand, okay? Generally this one is not necessary, a linear portion I am explaining, but some people, they will be feeling difficulty in drawing this circular diagram. So for those people, I am explaining simultaneously so that it will be very easy for you. Is it, guys? Now if we understand this one, I think I can erase this portion. Okay, those who want, they can place whatever segment 1 is there across here. Those who want, I am saying, those who want, they can show some brush across segment number 1, they can show some brush across segment number 3, they can show some brush across segment number 5, they can show some brush across segment number 7. Like this also you can show, no problem. Is it clear? Okay, now this portion I am just going to erase. This is not necessary for us, this portion is important for us, okay? But some people are feeling difficulty in understanding this diagram. For those people only, I just explain it simultaneously. Is it clear, guys? So right, I am just going to erase this portion, okay, guys? Right. Now I think you can explain this portion also, this remaining portion. So it's very simple. So please let me complete this portion. So third conductor is connected to which commutator? See, third conductor, third solid conductor is connected to third segment, and 5 dash is connected to which segment once again? You can say 4. This is completed. Next, fourth conductor is connected to what here? Fourth is connected to, I can say 4 here. And 6 dash is connected to what? 6 dash conductor is connected to which segment? I can say 5. And fifth conductor is connected to which segment here? 5. And 7 dash is connected to, okay, I can say 6. Similarly, sixth conductor is connected to which segment? 6th segment. And 8 dash conductor is connected to which segment? 7th commutator. Okay, 7th commutator. 7th commutator segments I can say. Next, 7th conductor is connected to, okay, 7th commutator segment, and 1 dash is connected to whom here? 8th segment. Next, 8th segment is connected to, okay, I am saying 8th conductor is connected to here 6 to 7, 7 to 8, okay. Next I am saying 8th conductor is connected to which segment? See, please try to understand. Here I said 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. Is it clear, guys? Now please tell me, 8th conductor is this one, this I cannot able to show here, that's why I just separated around here. 8th conductor is connected to 8th segment, 8th, and 2 dash is connected to whom here? 2 dash, this one, connected to 1. See, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 1. One second is complete. Is it clear? This is what I can say, developed diagram I can say, or I can say, linear portion, linear way of showing a lap winding, okay. See guys, here one thing you have to understand. So, okay, now let me show whatever this upward arrow mark brushes is there, let me short together. This arrow marks, this one should be short together, okay. And let me give one terminal name, I'll tell you, okay. And what about this one also? This downward and this downward. Okay. Okay guys, now let me see this upward arrow mark, they are shorted together. I just taken one terminal outside, and here downward, I just taken these two terminals once again. Okay, I have taken one more terminal outside. Okay, so please guys, now please try to understand, among those, let us assume that wherever current is coming, this one I can say, okay, and this one I can say, okay, this one can be taken as plus terminal, and this one can be taken as a minus terminal. See, it's very simple. Can you please tell me what is the reason why I just indicated upward arrow mark I just shown with the minus, and downward arrow mark I just shown with the plus. Okay, very simple. There is nothing. See, I am just discussing all those things in generator point of view. Okay, in generator point of view, if you see, if a brush is there here also one brush is there. Here in middle you will be having some commutator segments, all those things not necessary for us, and here some load is there, means, you know, suppose current is coming like this, okay, generally we will be placing, okay, I will draw once again, there is otherwise we will be having some confusion. So in a simple loop diagram, what I told, north pole, south pole, okay, and here commutator segments separated by mica insulation. Here are the brushes we are having. I can have brushes, I can place brushes here. X segment, Y segment is coil. Okay, here I am having some brushes. Suppose if I place some load here, you tell me guys, example, if current is going in AB conductor in upward direction, here CD it is downward direction. So here brush B1 is there, brush B2 is there, here it is coming like this, current is coming like this. Now tell me, always at load, current flows from plus to minus, no, it's plus to minus, and current, that means current is coming like this. Okay, it is coming like this, it's coming like this, it is going like this. Okay, so in generator point of view, I am saying wherever brush is there, from that brush current is coming outside, means that should be shown with what here, plus terminal. So that's the reason why I had taken coming outside. This should, I just marked with a plus. Suppose here brush, current is going inside, right? So in generator point of view, wherever brushes current is going inside, means that is marked with what I can say, minus. Therefore here this brush is marked with the minus symbol. Okay, so generator point of view I am just showing, it's not a very big deal, you can understand very simply. Okay, so ultimately DC machine, so you should get two terminals only, therefore I just showed plus and minus terminals here. Okay, so I think diagram seems to be very difficult, but it's very simple only. I just went very slowly. Now guys, let me do one more thing here. Yeah, here 1 dash is the coil here. Let me show like this. What is this coil name? 1 3 dash. 1 3 dash coil is connected between what segment? Segment number 1 and segment number 2, no? Yes, segment number 1 and segment number 2. Don't confuse. 1 3 dash coil is connected between segment number 1 and segment number 2. Okay, next another coil, what is that? 2 4 dash. 2 4 dash is connected between what? Second and third segment. Second segment and third segment. Is it clear? Right. Next, simply one more question I am asking. So let me take another conductor, please. This one completed, no? These two completed. Next, 3 5 dash. 3 5 dash is the coil, is connected between 3 and 4 segments. So third segment and fourth segment here. Next, and 4 and 6 dash coil. 4 6 dash coil is connected between what? Can say what? 4 6 dash connected between 4 and 5, no? 4 and 5th segment. Now once again, next remaining 1. 5 7 dash. 5 7 dash coil is connected between what segments? I can say 5 and 6. 5 and 6 segments. Okay, complete. Next 6 8 dash. 6 8 dash coil is connected between what segments? 6 and 7. 6 and 7. So next one please. 7 and 1 dash. 7 1 dash is the coil connected between 7 and 8 segments. 7 segment and 8 segment. Okay. Next this one. 8 2 dash. 8 2 dash is the coil connected between the 8th segment and the 1st segment. Okay guys, here already one segment is there. Let me give connection. One segment is going and is giving connection to segment number 1 means this portion. Okay guys, so let me extend this lines. Let me extend these lines. Now please try to let me show at segment number 1 guys. This is segment number 1. This was segment number 1. This segment number 1. This one. This segment number 3. Segment number 5. Segment number 7. Okay. Sorry. Segment number I can say. Yeah. Segment number 7. So at segment number 1, you are having one brush is there. No. Let me have one brush here. Say at segment number 1, let me connect one brush. And segment number 3 also one brush is there. Segment number 3 also one brush is there here. And segment number 5 also one more brush is there. At segment number 5, let me have one more brush here. And segment number 7 one more brush. Segment number 7 also one more brush. Okay, let me show here. Let me extend line here. Okay, right. Now at segment number 7 one more brush. Is it clear guys? Let me give numbering also for this let me give numbering A segment. Sorry, let me give a nomenclature for this brushes. A brush, B brush, C brush, D brush. Means your segment, whatever the brush connected to segment number 1, you are calling it as A. Means this one A, and this one B, and this one C, and this one D. Is it clear? Okay. Now, so generally, if you see this diagram, whatever the diagram just erased, that will be difficult for you, and this will be somewhat easy for you. This will be okay. And see, ultimately, I am just going to draw one diagram that becomes very easy for us. So let me show this brush. Let me show this brush. No, I am just going to erase this portion, guys. Here I need some space here, please. Try to adjust. Let me take 4 brushes here. In brush number A, brush number B, brush number C, and brush number D. A, B, C, D. Okay guys? Alright. Now please tell me. Between A and B brush, these are the two conductors connected. These are the two coils connected in series. 1 3 dash and 2 4. Don't confuse. These are the this is the name for coils. Okay. And what of this? This was this 1 and 2, 2, 3. This is nothing but names for complete segments. And top side, whatever I had given numbering, this is nothing but names for coils. This bottom ones means names for complete segments. Don't confuse with it. Okay. So 1 3 dash is the coil here, right? 1 3 dash. 1 3 dash coil, 1 3 dash coil, and one more coil. What is that? 2 4 dash. 1 3 dash. Okay. 2 4 dash. Next, between B and C, guys, these are the two coils connected in series. Okay. Between B and C. So let me give. Let me represent those two connectors. Okay. 3 5 dash means here 3 5 dash, and what is the one more coil? 4 6 dash. 4 6 dash. Next, between C and D, 5 7 dash. Between C and D, 5 7 dash. First of all, 5 and 7 dash here. Next, 6 and 8 dash. 6 8 dash. Next, between D and 1, these conductors, okay, these coils I can see. So 7 and 1 dash, 8 and 2 dash, 8 and 2 dash. Is it clear, guys? Okay. And I told one more thing. Among this A brush, which brushes are short together? So A brush and C brush are short together, no? A brush and C brush are short together. So let me short this. A brush and C brush are short together, and I think you might have known what is the terminal name I had given for this A and C. Minus I had given. So let me give minus here, and let me short B and D. B brush and D brush are shorted like this. Okay, guys. And what is the terminal I have taken outside? Positive terminal. Positive terminal. If you observe clearly, I already told that we are discussing generator point of view. So let me connect some load here so that you will be having some clarity. Let me connect some load after brushes here. Let me connect some load after brushes. Load. Okay. So see, guys, first of all, I think we explained in the brush number A, direction of current is into the brush. It is upwards, right? So that means it is entering into the brush. So it should be like this, and it is coming like this means obviously whatever total current I is there, it is coming and dividing as I by 2, and once again I by 2. This I by 2 is coming, and at C also it is entering like I by 2 only. If you can observe here at C also it is upward arrow mark only. Okay. And what about at B brush? It is downwards. Downward means arrow mark should be like this. Downwards means it is coming from the brush, no? Yes, it is like this. And what about from D also? It is like this. So it is like this. So I by 2 and I by 2. So total current it becomes how much here? I. So always you know what in a generator current flows at load from plus to minus. So plus to minus it is going. If you want, you can show internally also direction. Amount of current you can show. Very simple. See, I by 2 current is coming. It is dividing as I by 4, and once again how much? I by 4. And you told I by 2 current is one side is coming. No, it is coming here. Otherwise, see here. It is here I by 2 is coming, it is dividing I by 4 and I by 4. Okay. Now my question here is, here what is the total current I by 2 once again? So how much can I have to add to this I by 4 for getting this I by 2? So it should be like this, I by 4, I by 2 only. Is it clear? So here is the total current I by 2. It is dividing, it is coming and dividing as I by 4, and once again I by 4. If you see anywhere it will be, KCL will be valid. Okay. I by 4, total how much? I by 2. Yes, coming I by 2. Okay. Here see I by 2 dividing I by 4. Okay. I by 4, I by 2. Okay. So everything will be clearly, KCL will be clearly verified here. Okay, guys. Is it clear? So tell me, ultimately in this case, lap winding, this is the simplest diagram. For solving problems also, we will be using this portion. This diagram only I will be discussing. I will be taking. So in examination, GATE examination, it is not possible to draw all this diagram, this developer diagram, or the diagram in circular manner. All those things it is not possible to draw. Is it clear? So that's the reason I will be using this diagram in solving previous questions. Suppose if I draw directly this one, you will be having confusion. Sir, how you draw this one? So how you draw this one? So like that you will be having some confusion. That's why for making you to free from confusion, so I just explain this developer diagram. Before that, the main diagram, but circular diagram also explained. Please try to follow. Please try to practice once, twice, thrice. It will be easy for you. But guys, I'm saying I already told you this designing point of diagram. It is not necessary for GATE and IES or ESA, I can say, because they won't ask you to design all those things, right? So it will be useful for us in a ES examination for subjective type, for conventional questions. It will be useful for us. Is it clear? Okay. So please, your ultimate, what is the conclusion, guys? In lap winding, if you see here, what are the number of already given lap winding? What are the number of brushes means is equals to number of parallel paths I told equal number of poles I told. How many number of poles I taken here? 4 poles. Number of parallel paths 4. See, 1, 2, 3, 4. How many number of brushes? 4. 1, 2, 3, 4. Is it clear? I hope you understand clearly. Maybe if it is difficult for you, please try to practice once, twice. It will be easy for you. But I said it is important for people who are preparing for ES examination. For a subjective point of view, for conventional point of view, it will be useful. But for gate point of view, objective point of view, this much is not necessary. But you should be having some knowledge. Though it is not necessary, if you try to follow this one, some questions, if they ask difficulty, if they ask in a difficult way, if you know this concept, those questions can be solved in an easy way. So it is not, there is nothing wrong to learn new things, though it is not important for objective. So please try to learn. It will be useful for you in solving some difficult objective questions also easily. Okay, right. In the next video, I will be discussing about wave winding. Okay, guys. Thank you.